Hello everyone, hope you are doing well. I'm going to explain you this question. Uh, According to the question, what he is saying, what will be the interaction force between two copper spheres, each of mass 1 gram? Okay, so first of all, he has given what two copper spheres are there. So this, let us take, we have two copper spheres of each of mass how much? 1 gram, and both are separated by a distance of 1 meter. Let us take, these two are separated by a distance of how much? 1 meter. Okay, if the total electronic charge in them differed from the total charge of the nuclei by 1%. So whatever the total electronic charge is there, let us take this part as q1, okay, and let us take this part as q2. So both are both the charges are equal, he said, and both total electronic charge, let us take q1 is equals to q2 is equals to q. For our convenience, we'll take in this manner. So this is being differed by how many percent? He is asking 1% of its nuclei, total charge of nuclei by 1%. Whatever the total charge of nuclei is there, it is differed by 1%. So first of all, what we will do is we'll find out the number of atoms in a copper, okay, copper sphere. So first of all, to find out number of atoms is equals to, in 1 gram of copper, how much? In 1 gram of copper is how much? So I'll write here, in 1 gram of copper, in 1 gram of copper. So number of atoms in 1 gram of copper can be given as Avogadro number divided by the molecular weight of copper. So the molecular weight of copper is 63.55, and the Avogadro's number can be taken as 6.023 into 10 power 23 whole divided by the molecular weight of copper is nothing but 63.55. So we will get the number of atoms after dividing. I would like to write the direct solution here. So that is how much? 9.476 into 10 power of 21. So these are the number of atoms in 1 gram of copper. Once we got the number of atoms in 1 gram of copper, first of all we'll find out the total charge. So what is the total charge? Whatever the charge we will be getting, and then we have to take out its 1%. Okay, the total charge q can be taken as how many atoms are there? 9.476. I would like to take 9.476 into 10 power 21 are the number of atoms. And how many atoms are there in copper? That is 29 into charge of individual electron, that is how much? 1.602 into 10 power minus 19. I'm taking 1.602. okay, let us write here 1.602 into 10 power minus 19. After multiplying, we will get the total charge as, after multiplication, I would like to write the answer directly, 4.397 into 10 power 4, 397 into 10 power 4 coulombs. We got a total charge here. Okay, now what we need to find is, we need to find as the total charge of the nuclei by 1%. It is being deferred by total charge of nuclei by 1%. As it is being deferred by 1%, let's take here by 1%, means we need to take out the total charge, means the actual charge q will become, okay, or the actual charge q1 or q2. Q1 is equals to q2. I would like to take as the total charge, we will name here as capital Q for our convenience, because as we have given here as small q as the 1%, so what we will do here, we'll take it as capital Q. So I would like to replace this part by capital Q. Okay, here we represented capital Q, here we represent capital Q. So now q1 equals to q2 is equals to q is equals to the 1% of capital Q. So 1% of capital Q means we have to take 1 by 100 into the total charge, that is capital Q is how much? 4.397 into 10 power 4. As you know, 100 can be written as 10 square, and if I send the 10 square to the numerator, it will become 10 power minus 2, and as a result the actual charge will be 4.397 into 10 power 2 coulombs. So this is the individual charge. Okay, this is the total charge on individual copper sphere. Are you able to understand? Now we need to find out the force of attraction here. He's saying to, the answer is not over yet, we need to find out the force of attraction. Okay, so the force of attraction can be given as you know the formula, F is equals to 1 by 4 pi epsilon naught into q1 q2 by r square. Okay, so I can write the values here. The 1 by 4 pi epsilon naught can be mathematically taken as 9 into 10 power 9, and both the charges are equal. That is q1 is equals to q2 is equals to q. So I would like to take it as q square, and q square means we have the value right over here. That is 4.397 into 10 power 2 whole square, whole divided by r square. R square is nothing but the distance he has given as 1 meter. So I would like to take 1 whole square. Okay, anyhow denominator remains as usual. After simplification, we will get the final solution. I would like to write the value directly. That is 1.74 into 10 power 15 newtons. So this is what the final force acting between the two copper spheres of mass 1 gram, okay, and separated by a distance 1 meter. Hope you understood this question. Thank you. Well, in this question, what he's saying, two small charge spheres, each of charge small q and mass small m, are suspended from the same point by silk thread of length L. So indirectly, this here he has given the diagram. This is the length L, and here he has given two charges. Both are separated by a distance x as shown in figure. And now the first thing what he is saying, find the distance x between the sphere if x is much less than L. So this x is much smaller than the length of this term for the equilibrium of charges. And the second term he is asking, if the charge starts leaking from both the spheres at the constant rate dq by dt, find the velocity of approach. So indirectly, we need to bring here the relation x is proportional to which term in terms of charges, and here velocity is proportional to x, the proportionality term. So here we need to, if we are finding the equation, it will be very lengthy according to the options. I haven't give you the options here. Options are relation, the relation here, the velocity of approach in terms of x we need to find, and here we need to find out x in terms of the charge q. Okay, let's proceed for the solution for this one. Okay, let us just draw the free body diagram here. First of all, I would like to draw the free body diagram of the given question. Okay, roughly I'm drawing the free body diagram here. So this is what the charge, the first plus q charge, and this is what the second minus q charge. Okay, so now here we have the charge plus q, and here we have the charge minus q. Okay, and both are separated by a distance. He has given us in the question that both are separated by a distance x, that we will use later in our problem. Okay, well, coming back to the point, as the tensional force will be acting here, the tensional force will be split it here. The tensional force will be acting right or wrong? The tensional force will be acting in this direction, and meanwhile the vertical term he has given here, the vertical term, and the wire is making an angle theta with respect to vertical as he mentioned us in the question. So I would like to take this part here theta. So now this tensional force will be split into how many components? Two components. One will be going in this direction, the horizontal one, while the other one is nothing but your vertical one. Okay, so as it is making an angle with respect to the vertical, so this will become what? T cos theta, and this part will become what? T sine theta. And now I already he has given that the charge is having a mass m, and mg will be acting, its weight will be acting downwards right from here. Okay, now due to this positive plus q, the electrostatic force of attraction will be taken in this direction. Okay, so the electrostatic force of attraction I would like to take here. Okay, so it is acting in this direction, that is electrostatic force. Okay, now what we are going to do is we are going to just equate the horizontal terms and vertical terms here. So when I'm equating the horizontal terms, let's take the horizontal term here, that is a horizontal component, that is T sine theta is equals to Fe, that is electrostatic force of attraction. For an instant we will neglect the negative sign here. So the electrostatic force of attraction can be taken as 1 by 4 pi epsilon naught into q1 q2 by r square. First one is q, the second one is minus q. I would like to take directly, I would like to neglect the negative sign. The q by the distance between them is nothing but x and the square. So we can write here as T sine theta is equals to, directly I would like to write here q square by 4 pi epsilon naught into x square. Let's take this part as equation number 1. Hope you are clear with this one. Let's go for the second part, that we will equate the vertical component. When I'm equating the vertical component, that is T cos theta is equals to, we will get here as mg. Let's take this part as equation 2. Now I would like to divide both the equations, that is equation 2 equation 1 divided by equation 2. So now what I will do is, the LHS part of the equation 1 is how much? T sine theta whole divided by the LHS part of equation 2 is nothing but T cos theta is equals to, I can take here as equation 1 RHS part is what? Q square by 4 pi epsilon naught into x square whole divided by, here we can take it as mg, right? So I can cancel this t and this t, will get sine theta by cos theta is nothing but tan theta. Okay, so I would like to write the term tan theta is equals to, this part will be multiplied with the denominator and we'll get q square by 4 pi epsilon naught into x square into mg. Let's take this part as equation number 3, sorry, uh, equation number 3. Okay, now what I would like to do is, here the distance he has given us x. Let's indicate the distance right over here. The distance is nothing but how much? X. Let's take that distance. This is the distance x. If this is x and here he has given that this length is nothing but L, so this will become x by 2. Now anyhow, these two will be moving towards each other positive. So as these two are moving towards each other, at that instant what happens, the theta will become small. As theta will become small, in that case the sine theta and tan theta will be same here, right? So I can write here from figure, I can say directly that from figure sine theta, if theta, or else why to write this much directly, I can write here as the direct term I can write here, right? I'm writing here that if theta is small, if theta is small, if theta is small, then we can write here as sine theta is equals to what? Tan theta. That can be taken as opposite by hypotenuse. So this is nothing but x by 2 and here we have L. So I can write here as x by 2 whole divided by L, and as a result we can say it as a tan theta is equals to x by 2L. Let's take this part as equation number 4. Okay, so this is tan theta, this is tan theta. Can I equate both the equations? Yes, of course. I would like to equate the equation 3 and equation 4. So I would like to write here that is equating equation 3 and 4. When I'm equating equation 3 and 4, so you can say tan theta can be written as here x by 2L is equals to, the RHS part is nothing but q square by 4 pi epsilon naught into x square mg. As I said you, we need to find out the first one as in terms of x, as x is much less than L. So you can say here as x, if I send this x square towards the numerator, this will become x cube is equals to q square into 2L whole divided by 4 pi epsilon naught mg. So I can clearly say that as x is much less than L, so we need to bring the relation between x cube is directly proportional to q square. Do you accept this part? Yes, of course. So now if I remove the proportionality term right from here, so or else if I send this cube towards that side, so x is proportional to, I can say, q power 2 by 3. Do we accept this part? Yes, x is directly proportional to q power 2 by 3. This is the answer for our first bit. Okay, this is the answer for our first bit. So I will directly we will represent here that is q is directly proportional to x is directly proportional to q power 2 by 3. And now he's saying that if he's saying that we need to find out the velocity of approach. If I differentiate this equation directly, differentiating with respect to t, so this can be written as, differentiation of x can be written as, that is dx by dt proportional to x power n type. So I can write here n into x power n minus 1 into dq by dt. Do you accept this part? Yes, of course. So now dx by dt can be taken as velocity, right or wrong? So I'm taking that as velocity is proportional to 2 by 3 times of q power. Directly I can write here as minus 1 by 3 into dq by dt. But dq by dt, he said as what? Dq by dt is constant, at the constant rate of dq by dt, as he said. So I would like to eliminate that part. Now v is directly proportional to 2 by 3 into q power 1 by 3, but he has given the options velocity in terms of x. Can I replace our q term here in terms of x? So I can write here as q is equals to, okay, I can write here as q is proportional to x power 3 by 2. So when I'm taking that part here, v is directly proportional to 2 by 3 and q can be replaced by x power 3 by 2 whole power minus 1 by 3. This 3 and this 3 will get cancelled. Anyhow, 2 by 3 is also constant, so we will remove that 2 by 3 also. This 2 by 3 will remove. So finally, the answer we will get right over here is velocity is directly proportional to, I would like to write the final answer for the second bit as v is directly proportional to x power minus 1 by 2, or else v is inversely proportional to x power 1 by 2, or v is proportional to, inversely proportional to root x. As this is the answer for the second part, and this is the answer for the first part. Hope you understood this part. Thank you. Here in this question, what he has given, three small balls, each of mass small m, are suspended separately from a common point by a silk thread, each of length L. The balls are identically charged and hang at the corner of an equilateral triangle of side A, where A is much less than L. What is the charge on each ball? To understand this question, what you have to do, first of all, what are the common things? Three small balls. All the balls are having the same mass, that is M, and they are identical, that is the charges are same, and all are having the length L. To understand this question, first you must visualize yourself in the, we can say that you visualize the same the diagram in 3 dimension. Okay, assume that in 3 dimension, when you assume, and we will take the front side of the 3 dimension. When we see the front side of the 3 dimension, it looks like an equilateral triangle. That is what he's saying here he has given. So we will visualize that in the form of a 3 dimension, and we will simplify the force acting right over here, and then we'll proceed to the further question. So according to that, when we visualize according to 3 dimension, the front view we can see here is an equilateral triangle. So I'm drawing that equilateral triangle right over here, right? Okay, now here we have three charges, he said, and all the charges are same here. So I would like to name this part as point A, and this is nothing but our point B, and here nothing but our point C. Okay, now also he has given the sides here. The sides are how much? A. All the sides are same, so it's an equilateral triangle. Now what I would like to do is the force of attraction in this case. So the force of attraction right from A to B will be A to C will be acting in this direction. At point C we will assume, I will name it as FAC. Okay, and from B to C the force of attraction will be going towards right side. So I would like to take that part here, that is FBC. Now this is an equilateral triangle. The angle here is nothing but how much? The angle, sum of the angles in a triangle is how much? 60 degrees. So if this the angle right over here, I'm taking it as 60, so outer part will be also 60. Here sum of the angles in a triangle is 180, sorry. So here 60, here 60, and here 60, right? So if this is 60 means here I can say clearly this is the angle here is also 60. From the concept of our parallelogram laws of vectors, two forces are acting at an angle theta, then the resultant will be acting in this direction, and this direction, this force, will name it as Fe. This Fe nothing but the electrostatic force, and this electrostatic force is produced because of these similar charges on all the points, all the corners of a triangle. Are you able to understand? So firstly we will find out this Fe. Before that, as this is an equilateral triangle and all the sides he has mentioned that sorry, it's an equilateral triangle, the side of an equilateral is A. He has given the side of an equilateral triangle as A. So what we can say from here, we can clearly say that the force acting between BC will be equal to force acting between AC, as it is an equilateral triangle, and we will name it as F. And that F can be taken as what? Directly the charges are same here, so I can write here 1 by 4 pi epsilon naught into q square by a square. Do you accept this part? Okay, now next what I would like to do is the electrostatic force of attraction Fe can be taken as square root of f square plus f square, using the parallelogram laws of vectors, 2 into f, and theta, here theta is how much? 60 degrees. So I would like to take it as cos 60. So Fe is equals to, I can take directly this f square plus f square is how much? 2f square, and here we can take it as plus 2 into this f square as it is, and cos 60 is how much? 1 by 2. I can cancel this 2 and this 2, and finally I will get Fe is equals to 2f square plus f square, that is root 3 f square, or I can write, if I take out from the root, so Fe is equals to root 3 f. We got the electrostatic force of attraction. Now as we have assumed this part in a 3D shape, now what he is saying, it is being suspended from a common point by a silk thread. As it is suspended by a common point from a silk thread, so what I will do is, we will consider one part of our diagram. Okay, we will consider the one part of our diagram. So in an accordance to that, I will take in this format. So this is our view. From here, what we have from this particular point, a silk thread whose length is how much? L. Here the charge is there, any one charge we'll consider. Here one will drop it as vertical. Do you accept this part? Okay, here we'll just join these two terms. This is x by L. Here he has given the side now, this will become a by 2. Later we will consider this part. Okay, if this is the angle theta, and here we have the length L, this is having a length L, then the tensional force will be acting in this case. Do you accept this part? The tensional force will be acting in this direction. And also right from the center of the triangle, as this is 3D, I said you, from the center of the triangle or the centroid of the triangle to one of the vertices is taken as a by root 3. Hope you know this part. In an equilateral triangle, right from the center to any one corner, it is taken as a by root 3. And now this tensional force is acting in this case. The tensional force will be split into how many components? Two components. One will be acting in this direction, that is nothing but your t sine theta, while the other one will be acting in upward direction, that is nothing but your t cos theta. I'm taking that part here. Okay, this is our t cos theta. And then the weight will be acting downwards as usual, that is mg will be acting downwards. So I'm taking that mg will be acting downwards, and the electrostatic force will be acting in this direction. That's why I found out right from here the electrostatic force. Understood? So the electrostatic force we will take here. Okay, so that electrostatic force, I'm just indicating here, this is our electrostatic force. Clear? So now from this diagram I can say we'll just equate the horizontal component as well as the vertical component. First we'll equate the horizontal component. T sine theta is equals to what? Fe, and we got the value of Fe here, that is root 3. Fe is equals to root 3f, but we got the value of f right from here. So I would like to substitute. I would like to write here that Fe is equals to root 3 times of f. What is the value of f we got here? That is q square by 4 pi epsilon naught into a square. This is what the term, right? Clear? Fine. The next thing, so I would like to substitute here the t sine theta is equals to the value of Fe is what? Directly I can write here 3 into root 3 q square by 4 pi epsilon naught into a square. Let's take this part as our equation number 1. Now after equating the vertical components, we'll get it as t cos theta is equals to mg. Let's take this part as equation 2. When you divide equation 1 by equation 2, when we divide this part, we can write directly that t sine theta by t cos theta is equals to, I can write this term directly, root 3 q square. I would like to write directly this term, that is 4 pi epsilon naught into a square mg. This t and this t will get cancelled. Sine theta by cos theta can be taken as tan theta. So I'm writing here tan theta is equals to, here, tan theta is equals to root 3 into q square whole divided by 4 pi epsilon naught into a square into mg. This is the value of tan theta. So for our convenience, let us take this part as our equation number 3. Now from the figure we can say that if theta is small, then sine theta will be equal to tan theta, and that will be equal to, we can take it as this distance, as I said you, a by root 3 by this length, that is a by root 3 by L. So I would like to write directly a by root 3 by L, that L will be multiplied here. Okay, so this I can take it as equation 4. This is also the value of theta, this is also value of theta. You can say if theta is small or a is much less than L, we can write, or we can write it as theta is small, any one thing from both the terms. Okay, so any one thing you can write here. Now we will get, we are equating both the terms, so equating equation 3 and equation 4. I would like to equate equation 3 and equation 4. The LHS part of the equation 3 is, sorry, tan theta, the RHS part we'll take here, root 3 into q square whole divided by 4 pi epsilon naught a square mg equated to a by root 3 L. We are concerned to find out the charge on each wall, right? We are concerned to find out the charge on each wall. To find out the charge, here we have q, so I would like to keep this q square here, and remaining terms I would like to send on the RHS side. So I will get q square is equals to 4 pi epsilon naught into a square into a will become a cube into mg by root 3 into root 3 will become 3 into L. If I send the square there, it will become a root, and the final answer is q is equals to root over 4 pi epsilon naught a cube mg whole divided by 3L. This is the final answer for the given question. So this is nothing but the charge on each wall, the total charge on each wall. That's it. Thank you.